Okay guys, this is lesson video 3.5 on equation solving and modeling. The objectives are to apply the properties of logarithms to solve exponential and logarithmic equations algebraically. So we are just going to focus on the equation solving portion of this lesson. In order to help us solve equations, we're going to use these two one-to-one properties, one for exponential functions and one for logarithmic functions. The exponential one says that if b to the u equals b to the v, then u equals v. Alright, so that should make sense. If we have 7 raised to the x, and then we have 7 raised to the second power, then we could say that x is going to equal 2. Further, the logarithmic one, if we have log base b of u equaling log base b of v, then u equals v. So if we have log base 7 of x equaling log base 7 of 8, then x is going to equal 8. Alright, so we're going to use these two properties to help us solve equations. Okay, first example, we want to solve 20 times all this. Alright, so there's 3 steps that you want to follow in order to do this, and the first step is to get the exponential part by itself. So we're going to divide both sides by 20. Alright, so we're going to get 1/2 raised to the x divided by 3 equaling 1/4. 5 over 20 is 1/4. The second step, what you want to do is get the bases to match up. So here I have a base of 1/2 raised to the x divided by 3. Here I have a 1/4, and so what I want to do is I want to rewrite this. I want to rewrite 1/4 with a base of 1/2 if I can. So 1/2 is going to equal, 1/4 equals 1/2 raised to the second power. So, alright, I have now an equation in which I have the same base. Using the one-to-one property for exponential functions, I now set the exponents equal to each other. So I have x over 3 equaling 2, multiply both sides by 3, and so I get x equaling 6. Alright, another way I can solve this is by turning this into a logarithmic equation. The first step is the same. Divide both sides by 20 to get the exponential part by itself. So I have 1/2 to the x over 3 equaling 1/4. And so what I can say now is that log base of 1/2 of 1/4 is going to equal x divided by 3, and we solved these in section 3.3, I believe. So we're looking, so log base 1/2 of 1/4, that's really what we want to find, is 1/2 raised to what power of x equals 1/4. Alright, so x is going to have to equal 2 in this case. So this left hand part of the equal sign is going to be 2. That's going to equal x over 3. Alright, and so multiplying both sides by 3 again, we get 6 equals x. Alright, so 2 ways that you can solve these. I think the first way is a little bit easier. Okay, in example 2 here, again we're solving another exponential equation, and this is probably going to be the hardest one that we're going to solve of the 4 that we're going to be doing. And so we're going to write e to the x. I'm going to need some more room. Right, so let's do e to the x minus e to the negative x over 2, and that equals 5. And then let's multiply both sides by 2 to get the 2 out of the denominator. So we're going to have e to the x minus e to the negative x equaling 10. Okay, there's going to be 2 tricks that we're going to use in order to solve this. Alright, and so you want to pay attention here. The first trick is we're going to multiply both sides by e to the x. So we're going to have e to the x times e to the x minus e to the negative x equaling 10 times e to the x. Okay, so now go ahead and distribute, and when I multiply e to the x times e to the x, I have powers with the same base, so I'm adding their exponents. So x plus x is 2x minus e to the x plus negative x, that's just going to be e to the 0, equals 10e to the x. Alright, and now I'm going to take this 10e to the x and move it on to the left hand side of the equation to get e to the 2x minus e to the 0. Nope. Let's write this in better order. So e to the 2x minus 10e to the x minus e to the 0 equals 0. Okay, so that looks good. Now, the second trick is going to be letting w equal e to the x here. So e to the 2x, that's the same thing as saying e to the x squared. So I'm going to let e to the x equal w. So I'm going to have w squared minus 10w minus e to the 0 power is just 1, and that's going to equal 0. So now I have a quadratic, and what I want to do is solve for w. And in order to do this, you can't factor this. You're going to have to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Alright, so go ahead and plug in 1 for a, negative 10 for b, and negative 1 for c, and solve for w. When you're done with that, as you're doing it, press pause, and when you're done, hit resume and check your answer. Okay, so hopefully you have w equaling 5 plus or minus the square root of 26. Now, what is w? So w is e to the x. All right, we substituted w in for e to the x. So now let's substitute back. So e to the x equals 5 plus or minus the square root of 26. Now, e to the x cannot be negative, so e to the x is just going to equal 5 plus the square root of 26. Alright, I'm not done though. I have to find what x is, and so in order to do that, I'm going to multiply by the natural log, both sides. So I'm going to have the natural log of e to the x equaling the natural log of 5 plus the square root of 26. Alright, so the natural log, so this right here is really log base e to the x. And so what does this equal? So e raised to what power of x equals e to the x? Well, it's just going to be x. Alright, so that was the reason for multiplying both sides by the natural log, to get x by itself. So x equals the natural log of 5 plus the square root of 26. And so x is approximately going to be, when you plug this into your calculator, 2.31. Alright, so the hardest one is out of the way. On to the third one. Alright, now we're going to turn our attention to solving logarithmic equations. So when you want to be careful, when logarithmic equations are solved algebraically, it's important to keep track of the domain of each expression in the equation as it is being solved. A particular algebraic method may introduce extraneous solutions, or worse yet, lose some valid solutions, as illustrated in example 3. Alright, so we're gonna solve this using 3 different methods. And one of them the last one we're going to lose a valid solution. And hopefully explain to you why that is. All right, but the first two methods here are gonna work. All right, so solve log of x squared equaling 2. The first thing, the first method, we're going to use the one-to-one property of logarithms. So we have log base 10 of x squared on the left, and so I want to rewrite 2 as a logarithm, and that logarithm has to be base 10 because I want it to match the left-hand side. So log base 10 of what is going to equal 2. Well, 10 raised to the second power is going to equal 100. All right, so log base 10 of 100 is going to be what this right-hand side equals. All right, because we want it to be 2. So to check that this is 2, 10 raised to the what power of x equals 100? Well, x would have to equal 2. So this whole side, that's going to be, that right-hand side of the equal sign is 2. So it's nice because now I have log base 10 on both sides. Boom and boom. And so I'm going to set x squared equaling 100. And so x is going to equal plus or minus 10. Alright. Another way I can do this, alright, is to change the equation from logarithmic to exponential form. This is probably the easiest of the two methods, so we're going to have log base 10 of x squared equaling 2. So 10 raised to the second power is going to equal x squared. So 100 equals x squared. So x equals plus or minus 10. Okay? Now, another method that you may be tempted to use would be to use the power rule. So you may be tempted to take this 2 and move it in front of the log. So you'd say you'd say 2 times the log. So we're going to move the 2 here. So we're 2 log of x equaling 2. Then you may be tempted to say, okay, divide by 2 here. So we'd have log of x equaling 1. This is really log base 10 of x equaling 1. Alright, and so now 10 raised to the first equals x, so 10 equals x. Right, so with this method, what the issue is one of my solutions is lost, becomes lost, and that would be x equaling negative 10. So why does it become lost? Why do we lose it? Okay, so we start with log of x squared equaling 2. The log of x squared, the domain of this. So we can't have a log that's negative. Well, x is being squared, so it's almost impossible to get a log that's negative. So the domain for the original here is going to be any non-zero number. So the domain is going to be from negative infinity to 0, and then from 0 to positive infinity. Alright? Now, when we take the 2 and move it out in front of the log, then we have 2 log of x equaling 2. So now, let's look at the domain. The domain for log of x, alright, is a lot more restricted. We know that the log has to be greater than 0, so here the domain is going to be from 0 to infinity. Alright, so essentially by moving this 2 out in front, I change my domains, and in doing so I end up losing a solution. Alright, last example here. We want to solve this big logarithmic equation. What we're going to do first is rewrite the natural log. Let's rewrite this as the natural log is really log base e. So log base e of 3x minus 2 plus log base e of x minus 1 equaling 2 times log base e of x. Alright, and so I rewrote that so I could use my so I can use the product rule. So I'm going to say log base e of 3x minus 2, so I'm going to condense this, times x minus 1. Alright, so go back to 3. If you're not getting that step, go to 3, back to less than 3.4. So, and then this is going to equal 2 times log base e of x. Now, what I'm going to do here is I want both sides to have log base e. So I'm going to take my 2 and move it into the exponent for x here. So that's the power rule in reverse. So I'm going to have log base e of x squared. Now remember, so now we're changing our domain here. Alright, and so we can expect, since we've moved this 2 out into the exponent of x, we can expect to probably have an extraneous solution in this problem. Alright, so both sides, log base e of something equals log base e of something. Set those somethings equal to each other. So 3x minus 2 times x minus 1 equals x squared. Right, FOIL, so we have 3x squared minus 3x minus 2x plus 2 equals x squared. So I'm going to have subtract x squared from both sides, so I have 2x squared minus 5x plus 2 equaling 0. Alright, so now I'm going to have to factor this by grouping. So I have 2x squared minus 5x plus 2 equals 0. So I'm going to be looking for factors of a times c that equal negative 5. So 2 times 2, a times c is 2 times 2. So I want factors of 4 that sum to negative 5. So it's going to be negative 4 and negative 1. So I'm going to use these to rewrite this. So I'm going to have 2x squared. Now what goes best with the 2x squared? It's going to be the negative 4x. And then I have a minus x plus 2 equaling 0. Factor out of 2x, so I have x minus 2. Always put a plus sign here. And then negative x plus 2 equaling 0. Okay, so I have 2x times x minus 2 here. Alright, factor out a negative 1. Alright, make sure you did this right. These match up. So now you set what's outside the parentheses equal to 0. So 2x minus 1 equals 0. And x minus 2 equals 0. So x equals a half. And x equaling 2. Now we want to check these, because remember here, by moving this 2 into the exponent, we changed our domain. So probably have an extraneous solution that we have to check. So if I plug in 1/2 here for x, 1/2 minus 1 gives me a negative in here. So you can't take the natural log of a negative. So x equaling 1/2 is going to be the extraneous solution. If I plug in 2, 2 will work. I'll get positive here, and that'll be positive. Alright, so x equaling 2 will be my answer, will be my solution. Alright, so hopefully this video helps, and you guys will be good doing the homework in class tomorrow.